Hey guys, so today we're going to be looking at a harmonic series, and we're going to be using the direct comparison test to see how it diverges. So we already know that a harmonic series is a type of P series. So P series is 1 over n to the P, and a harmonic series, P equals 1. So we can rewrite this as 1 over n, because it's 1 over n to the first, which is equal to 1 over n. And we already know that the series is going to diverge, because in a P series, if P is less than or equal to 1, the series will diverge. And in this case, P is equal to 1, so the series will diverge, which we already know. So let's start out by writing out a few of the first terms. So the first term is 1 over 1, which is 1/2, plus 1, or this first term is 1 over 1, which is 1, plus 1/2, plus 1/3, plus 1/4, plus 1/5, plus 1/6, plus 1/7, plus 1/8, and so on. So just looking at the series, it actually kind of looks like it's going to converge, because the numerator is staying the same and the denominator is constantly increasing. So as n approaches infinity, 1 over n looks like it'll approach 0. And it does. So, however, the series actually diverges, which we know. So we're going to prove this using the direct comparison test. So for the direct comparison test, 0 is less than or equal to some series b sub n, or some series a sub n, sorry, which is less than or equal to some series b sub m, which in this case is the harmonic series. So essentially, for this direct comparison test, if we can prove that the smaller series diverges, and that means that the bigger series, the harmonic series, also has to diverge, which is what we want to show. So now we have to come up with some series b sub n, which all the terms are less than or equal to the terms of the harmonic series, and we have to prove that this series diverges. So for this series, we're going to use powers of 1/2. So starting off with the first term, we have to find the greatest power of 1/2 that is less than or equal to the term. So in this case, we have to find the one that's less than or equal to 1. Well, in this case, it's just 1, because 1/2 to the 0th power is 1, and 1 is less than or equal to 1. The second term is going to be 1/2, because 1/2 to the first power is 1/2, which is less than or equal to 1/2, so that works. 1/3, well, 1/2 is greater than 1/3, so we can't use that. So we're going to have to move on to the next power of 1/2, which is 1/4. So 1/4 is less than or equal to 3, so that works. For the next term 1/4, we're also going to use 1/4, because it's, again, less than or equal to 1/4 already. And then we're going to have to do 1/8, because that's the next power, and 1/5 is greater than 1/8. 1/6 is also greater than 1/8, so we're going to use 1/8 again. 1/7 is also 1/8, and 1/8 is also going to be 1/8, because it's less than or equal to 1/8, and so on. So now we can find the sum of b sub n, and we have to prove that it diverges. So the first term is 1 plus 1/2 plus 1/4 plus 1/4 is 2/4, which is 1/2. 1/8 plus 1/8 plus 1/8 plus 1/8 is 4/8, which is 1/2. And if we keep on going, we're actually going to see that we'll have 8 sets of 1/16, 16 sets of 1/32, and so on. So basically, we keep adding 1/2. Keep adding 1/2. So, and since we keep adding 1/2, the same number, the series is going to diverge to infinity. So since we proved that b sub n diverges, that means, since we proved that a sub n diverges, that means that b sub n will also diverge. And that is why the harmonic series diverges.